Welcome to the F5 Networks Advanced Web Application Firewall Demo and Exercise Series. In this exercise, we'll help you understand how to use parent and child security policies with BIG-IP Advanced WAF. This is an exercise which represents Demo 25 of the AWAF demo series, and it's intended for intermediate to advanced level BIG-IP Advanced WAF users. For optimal viewing, we recommend using full screen mode. The environment for this exercise contains 6 devices. We have an F5 BIG-IP system, running Advanced WAF. The BIG-IP system sits in front of, and protects, 3 backend web applications. We'll be creating a BIG-IP Advanced WAF parent security policy, which contains several application security settings. The parent policy will be used to create 3 child security policies, 1 for each web application. And finally, 2 workstations, 1 within the United States, and 1 within Syria, will be used to submit requests to the 3 web applications. First, let's examine one of the virtual servers we'll be using during this exercise. On the resources page, you can see that we have an iRule attached to this virtual server named Syria, North Korea, iRule. This iRule modifies the source IP address of requests coming from the Syrian workstation. All 3 virtual servers are configured with this iRule. Next, we'll create a parent security policy. We'll give the parent policy a name. Then for policy type we'll select parent. By using a parent security policy, we can define all required settings that other security policies must adhere to. We'll use the comprehensive policy template. We'll also disable signature staging. And finally, we'll assign server technologies, including Apache Tomcat, PHP, and Unix/Linux. Next, we'll select the Inheritance Settings page. We use this page to define the settings that all other security policies must adhere to. Mandatory settings require child security policies to inherit the settings. Optional settings allows the creator of each child security policy to decide whether to inherit the settings, or not. And none disables inheritance for the category of settings altogether. We'll adjust a few of these settings. Note that we're defining data guard, IP addresses and geolocations, and server technologies, as optional. We'll now save these settings. We'll now return to the Policies List page and create a child security policy for the first web application. We'll give the policy a name, and we'll leave the policy type set to security. We'll then select the parent policy. By selecting a parent policy, we're making this a child security policy. Finally, we'll select the correct virtual server. Notice that we can't modify several policy settings, such as the application language, the learning mode, and the learning speed. This is because the policy building process category is marked as mandatory in the parent policy. On the Inheritance Settings page, notice that some settings are inherited, which are marked as mandatory in the parent policy, and others are not inherited, which are marked as none in the parent policy. 3 categories: Data Guard, IP addresses and geolocations, and server technologies, have a decline button, because these categories are marked as optional in the parent policy. For this child security policy, we'll leave these settings as is, which means we'll accept the optional settings from the parent policy. We'll now create a child security policy for the second web application. We'll select the parent security policy and the correct virtual server. On the Inheritance Settings page, for this child security policy, we'll select to decline the optional settings for Data Guard, IP addresses and geolocations, and server technologies. Let's select the parent policy, and then view the Inheritance Settings page again. You can use this page to see which child security policies have accepted, and which have declined the optional parent policy settings. Before we move on, we'll change the attack signatures category to mandatory. We're modifying this setting now due to a minor bug in BIG-IP Advanced WAF version 15.1. We'll now examine the parent policy settings that can and cannot be modified in a child security policy. On the General Settings page, we'll select to enable the TrustXFF header option. This setting will enable BIG-IP Advanced WAF to use the modified IP address in the I rule as the source IP address. We'll now save the settings, and then view the settings for the first child policy. Because the General Policy Settings category is marked as mandatory in the parent policy, these settings can't be changed in child policies. Notice we cannot remove a server technology from the child security policy. Because we chose to accept this category's settings for this child security policy, we can't remove the options that were configured in the parent policy. We'll now attempt to add a server technology. Although we can't remove items from this list, we are able to add additional server technologies to the list. We'll now view the settings for the second child policy and attempt to remove a server technology. Because we chose to decline this category's settings for this child security policy, we're able to delete options that were configured in the parent policy. Also notice that the server technology we added to the first child security policy isn't reflected in this security policy. We'll now define some additional policy settings for the parent policy, using the Learning and Blocking Settings page. First, it's important that when you're managing more than one security policy on the same BIG-IP system, that you ensure you're viewing the correct policy before making changes. We'll select the parent policy. Notice there are less options to configure on this page for parent policies. We'll expand the Attack Signatures section, and we'll add the Medium Accuracy signatures, the Cross-Site Scripting signatures, the Other Application Attack signatures, and the SQL Injection signatures. In the Data Guard section, we'll clear the Block checkbox. This is important if you want Data Guard to just mask credit card numbers, but not block pages. We'll also configure learning for file types. In the General Settings section, we'll select the alarm and block checkboxes for the request length exceeds defined buffer size violation. We'll disable learning for parameters, and then we'll clear the learn, alarm, and block checkboxes for all parameter violations. Finally, notice that there is no URL section, as it's not an inheritable security policy category for parent policies. We'll now view the settings of the first child security policy. Notice on the right side of the attack signatures row, there is an icon indicator identifying that this section is inherited. You'll see that we cannot remove any of the signature sets. We'll add the command execution signature set. Because the attack signature category is marked as mandatory in the parent policy, attack signatures cannot be removed from the child policy. However, additional signature sets can be added to the child policy. Keep in mind that this additional signature set will not be reflected in any other child policies. The Learn New File Types setting inherited the parent policy setting, and it cannot be changed, because the file types category is marked as mandatory in the parent policy. The general settings also cannot be changed, as this category is also marked as mandatory in the parent policy. However, the settings in the headers sections can be modified for the child policy, as this category is marked as none in the parent policy. We'll now view the settings for the second child security policy and view the attack signatures section. Notice that the command execution signatures set is not included, as it was assigned in a child policy. We'll open the Data Guard page and select the parent policy, and then enable the Data Guard feature for both credit card numbers and US Social Security numbers. When we select the first child security policy, notice that we cannot change the Data Guard settings, because we chose to accept this optional category. When we select the second child security policy, you'll see that Data Guard is not enabled, because we chose to decline this optional category. On the geolocation enforcement page, again we'll select the parent policy, and then we'll select to disallow access from Syrian Arab Republic. We'll now save and apply the parent policy. The first child security policy is now configured to disallow this geolocation. And this geolocation cannot be removed, because we accepted the optional IP addresses and geolocations category. We can, however, add additional geolocations to the disallowed list for this child policy. The second child security policy is not configured with any disallowed geolocations, because we declined the optional IP addresses and geolocations category. We're now going to open the parameters list page. Then select the wildcard entry and clear the Perform Staging checkbox. We're making this change so that BIG-IP Advanced WAF won't allow requests with attacked signatures that we'll be submitting shortly. We'll now apply the child security policy. We'll also made the same modification to the first child security policy. We're now going to use an iMacro in Firefox to simulate traffic going to both web applications. We're using this iMacro to begin building both child security policies. Let's examine the traffic learning page. The first child security policy is already learning file types. The second child security policy is also learning file types. This shows that file type enforcement is underway for both child security policies. We'll now log into the DVWA web application as a malicious user. And then attempt a command execution attack. The attack is blocked by the BIG-IP Advanced WAF child security policy. Next, we'll attempt a SQL injection attack. This attack is also blocked by BIG-IP Advanced WAF. Finally, we'll submit a request with a credit card number. The credit card number and the HTTP response is masked. This web application is already protected against common attack signatures and information leakage. We'll now access the second workstation, representing a workstation from Syria. When we attempt to access the DVWA web application, we are blocked, because we are connecting from a disallowed geolocation. We'll now use the workstation from the United States to access the Hackerson web application, and attempt a command execution attack in the search field. We'll also attempt a SQL injection attack. We'll visit the FAQ page. And submit an entry that includes a credit card number. Although this web application is already protected against common attack signatures, it is still vulnerable to information leakage. We'll again use the workstation located in Syria and attempt to access the Hackerson web application. The request from this disallowed geolocation is allowed. Do you know why the Hackerson web application is still vulnerable to information leakage and can still be accessed by workstations from Syria? Let's open the second child security policy, representing the Hackerson web application, and then open the inheritance settings page. Remember that we chose to decline the data guard and IP addresses and geolocation settings. We'll now clear the decline option for both of these, which means we're now accepting these optional settings from the parent policy. On the US workstation, we'll reload the FAQ page. the web application is immediately protected against information leakage. On the Syrian workstation, we'll reload the page. The request from this disallowed geolocation is now blocked. Next, we'll simulate a new application attack, and then show how to use the parent policy to quickly protect all web applications against the new attack. This represents a new web application attack. Currently, both web applications are vulnerable to this new attack string. On the attack signature list page, we'll create a new, custom, attack signature. We'll give the attack signature a name, and then set the type as Other Application Attacks. This will automatically add this new attack signature to the Other Application Attacks signature set, which we've already added to the parent policy, and defined as mandatory for all child policies. We then need to identify a part of the new attack string. In just a few seconds, both web applications are now protected against this new attack threat. In the final part of this exercise, we'll create a third child security policy for a new web application, to quickly protect it using all the security we defined in the parent policy. First, we'll change the attack signatures category back to none in the parent policy. We'll now create the third child security policy. For the bank virtual server. For the parent policy, we'll change the attack signatures category back to mandatory. On the parameters list page, we'll first ensure we're viewing the settings for the bank security policy, and then we'll modify the settings for the wildcard entry. And then apply the policy. On the US workstation, we'll now access the banking web application, and we'll attempt a SQL injection attack in the login field. We'll also attempt a cross-site scripting attack using the login field. We'll now log in. And submit a new transaction. Adding the new application attack. Finally, we'll add a new transaction. including a credit card number. Because we used parent and child security policies, this new web application is immediately protected against common application attacks, new attacks, and information leakage. On the workstation in Syria, we'll attempt to access this new web application. The new web application is also immediately protected from disallowed geolocations. Thank you for watching this exercise on how to use parent and child security policies with F5 BIG-IP Advanced WAF. We encourage you to watch additional AWAF demos and exercises, and for more details on how Advanced WAF can protect your web applications, contact your F5 Networks Sales Account Manager. For questions or comments about this video, contact Chris Manley at the email address at the bottom of the page.